Now these two events, light leaving point A and light arriving at the same place, event B, happened at the same place in space and at different times. As a result, for that situation, we call this interval timelike, because we can let a time run between two events at the same place. Sometimes we have two events that happen at the same time, but in different places. So for example, maybe a particle decays in LA and an identical particle decays in New York. In this case, if I take my equation here, delta t is 0. These two happened at the same time. So this term goes to 0, and the whole thing is just negative delta x squared. Notice that means I can't define a sensible delta tau. Delta tau squared would be negative, which means delta tau would be imaginary. But that doesn't mean that this equation isn't still useful. Instead, what I do is I imagine, instead of having a proper time, a proper distance. That is this delta x squared, where the two times are the same. Then this quantity is still invariant. I call this delta x squared delta sigma. That's simply the distance between two events in a frame where the time is the same. And that is always equal to delta x squared minus the speed of light times the change in time squared. Notice a couple of really important things here. This quantity is invariant, but that means if delta x is bigger than c delta t in one frame, then it's bigger in all frames. Also, that means that two events that are simultaneous in one frame, if in one frame delta t is 0, in another frame delta t will not necessarily be 0. We'll have a bigger delta x, and we'll have a delta t that is not 0. In other words, two things that are simultaneous in one frame are not simultaneous in all frames. Two events like this, where the distance between them is greater than the speed of light times the time between them, are said to be space-like separated, or it's a space-like interval. The reason is that we can choose a frame where they happen at the same time, where delta t is 0, but the distance is not 0. We can choose a frame where they're simultaneous. And that is true for any two events where delta x is bigger than c delta t, where getting from one to the other would require moving faster than the speed of light. Events such as A and B here, we can get from one to the other by moving slower than the speed of light. C delta t is bigger than delta x, so these are said to be time-like related, or the interval between them is time-like. There is, of course, a boundary between time-like and space-like, and that's for the case where delta x is exactly equal to c delta t. In other words, the case where you're traveling at the speed of light. In that case, if the two are equal to each other, c delta tau equals delta sigma, and they're both 0, these are said to be a light-like interval or a null interval. Notice that means for this quantity, c delta t squared minus delta x squared. In this case, that's equal to 0 for all frames of reference. In other words, in every frame of reference, something traveling at the speed of light still travels at the speed of light.